Okay, so hi everyone. I believe I'm audible and visible, guys. So please confirm if you can see me and if I'm audible to all of you. Okay, everyone. So let me share my screen. Today's topic is going to be very, very amazing. So we are going to build 10 agent back to back and we are going to test it. We are even going to trace all of those agents. So technically, we'll be talking about a practical manner how we can try to build those 10 agent that we have discussed yesterday in a sequential manner. Not just that, so we'll try to even check the behavior. So let's say if I'm trying to build an agent, so whether those agents are working the way it was supposed to be or not. So that's a whole idea that we are going to basically test, we are going to check. So open up your VS Code, guys, and let's start building those 10 agents. And believe me, after this class you will be having enough amount of confidence to understand and to build agent for any kind of a use cases. So 10 agent super 30 May. Okay. So let's try to build it. So first of all, guys, you have to do a couple of installation. So let's say if I'm going to open up one file, so 10 agents file .ipynb. And here, so obviously I have to do a couple of installation and then only I will be able to build it. So first of all, let me write down that what and all kind of a agent I would like to basically build so that we'll be having an understanding about it. So here, the very first agent that we are going to build today is a simple tool agent. Simple tool agents. I mean, like I'm going to create one function, I'm going to give a function access and I'll try to check so whether it is able to do a tool calling or not. The second kind of a agent that we are going to build is called as a reactive agent. So yesterday we have already discussed. So there can be an agent so which can keep on trying, keep on doing a reasoning, keep on doing calling a action, keep on generating a responses. And yes, so it should run inside a loop unless and until it is not going to complete the task. So that is a reactive agent. So we are going to build that kind of a agent as well. So reactive agent. The third kind of agent that we are going to build is a router agent. So which is going to route things to one like another depends upon the condition that we are going to give. Then a planning agent we are going to build basically. Then we will be building a reflection agent, so which can look into its own decision and then cross check. And then we are going to build basically a memory agent. Then we are going to build basically human in loop, human in loop, HILT, HILA, basically human in the loop, HITL, human in the loop agent we are going to build so that it can ask for a human to approve or disapprove or maybe ask a human for some sort of a input. Then a multi supervisor agent, multi agent supervisor, agent 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 supervisor. Then we are going to build a handoff agent which can hand over a task to the next one. And then we can try to build basically a autonomous agent, so which can do a task in a automatic manner. So these are the 10 agent, guys, we are going to build in a step by step manner. We are not just going to build it, we will be like a tracing each and everything, and plus we'll try to even observe that whether this agent is working as per the expected rule that I'm going to set, or as per the expected tool that I have given, or as per my expected state which I'm trying to set, or as per the expected basically a system prompt which I have set. So each and everything we will try to even observe. Now to observe all of these agents, so I need an access of something called as LangSmith, which is going to help me out in terms of observing those agents. So just go to Google and then try to search for LangSmith, LangSmith. So LangSmith is a platform so by which you will be able to observe any agent that you are going to build in a Lang chain or maybe a Lang graph. So I'm pinging you this link, guys. Quickly log in inside this one with the help of Google login and confirm inside a chat once you are able to log in. Yeah, so just do a Google login, guys. It will be quick. And confirm inside a chat box. Yeah, done, everyone. So it will be very quick. So here, tell us more about yourself. So let's say I'm a technical person. This. Start building, right? So after like filling all those questionnaire, in any kind of a selection, so you will be landing into this particular window. So with the help of this particular window or this particular interface, you will be able to trace all of your agents. So here you will be able to see a tab called as tracing, right? So you can come over here and then you will be able to trace. As of now, there is not nothing you will be able to find out, by the way. So you can come over here, you can try to create a project, and then you can try to trace those projects. Now to connect with a LangSmith, because it is available inside a LangSmith server, I mean like on a cloud platform, right? So it is available. So if you have to trace this particular one, you have to generate your own API key. Unless and until you are not going to generate your own API key, it will not be able to trace it. And which is very simple, by the way. So where you will be able to create your own API key, simple. Here you will be able to see a setting button, left hand side, bottom, before your like a personal information. So setting button, click inside a setting, and then here you will be able to see a very first option called as API key. So what you can do, you can just click on this API key and then personal token, give a name to like this one. Let's say I'm giving a name as 10 agents. Fine. So it is going to basically generate a API key. You can set a duration of a expiration for the API key. Simple, right? So for a personal access token, you can try to set it up. So here, if I'm going to click, it is going to give me a API key. As of now, it's free. You will be able to test it. You will be able to use it. So once I'm able to generate my API key, I can keep it here. Yeah. So let me like keep it over here. And I will be using this particular API key to access my LangSmith. So I'll show you how to configure it, which is very, very simple. Within a minute, you will be able to configure it. And then you will start tracing your entire, I would say, application or agent or whatsoever call that you are going to do, a tool calling, everything, it will be able to trace it automatically. And then you will be able to see all of those things which it is going to trace in a, just click back and then here come to a tracing, and here you will be able to see it. As of now, this playground is going to be blank because you have not started any kind of a project, right? But yeah, so as soon as we are going to start, so obviously it is going to trace it and I will be able to see each and everything in a detail and depth over here. Fine, done, everyone. So are we able to generate API key? Yes. Fine. Okay. Now, so coming to the next point, basically, so second API key which I need is maybe a Open API key or maybe a Gemini or maybe a Claude or any kind of a API key I want. Because I need a LLM access, and without LLM access, obviously I can't go and build the agents because LLMs are going to be a brain for an agent. So you can go to Open AI and then you can generate your own API key. So simple, go here and then OpenAI API key, and then you can generate your own API key from OpenAI API platform. This is also very simple. So API key platform, login into API key platform, and then log in with the Google. And here, so you will be able to see an option called as API key. Now from here, so you can try to create your own API key. So create a new secret. I can give a name to it and then create a secret key. And I can try to use this particular secret key which it has created. As simple as that. So these are the two API key I need. So from here, I will be using a LLMs. So whatsoever LLM which I want, a latest version, oldest version, doesn't matter at all. One API key and I will be able to access everything. I can use even a Gemini. I can try to use even a Kimi K3. I can try to use even a GLM series. I will be able to use anyone and everyone basically to access my LLMs. At the end of the day, I need best of best LLM which is available in a market. As simple as that. Not even best. I mean like I need some LLMs, so which is kind of a moderately good, basically in a market. So fine, I can use OpenAI, I can use Claude, I can use Gemini, I can use whatsoever I want at any point of a time. So these two API key, you have to keep it ready. And then then you have to do a couple of installation in a very first place. So let's go ahead and let's try to do couple of installation inside your Jupyter notebook. So I'm going to use LangChain, I'm going to use LangGraph, I'm going to use LangSmith. So these three things are pretty much required. Along with that, so I'm going to use a Pydantic class as well for a validation. I believe we have already used it inside my fast API classes, right? So these are the installation which is required. So one is a LangChain, LangGraph, LangChain OpenAI, LangSmith, or basically Pydantic. So these installation you have to do it in your current environment. So first of all, I'll go and select the kernel, and I'm going to select a Python environment. Let's say 3.14 I'm going to select, and then inside this environment I will be installing each and everything. Yeah, so let me ping you this installation, guys. Fine, done everyone. So are we able to do installation? This is going to take some time for the very first time in my this particular environment. So it's already installed. So it is telling me that requirement already installed. If you're doing it for the very first time, so 30 second or maybe 45 second it is going to take, because it is going to install LangChain, LangGraph, LangChain OpenAI, LangSmith, and Pydantic. So all five it is going to install it. So once installed, please confirm inside a chat so that we can go ahead with the next one. And these are the only installation you need. So two API key, one is LangSmith, one is OpenAI, and then this installation, and then we are good to go. We can back to back start building an agent number 1, 2, 3, 4, 5, 6, whatsoever agent that we have written over here. So we can start building it. So confirm me, guys. Installing, yeah, it will take some time. I mean, like for first time, so it's a five library, and this LangChain, LangSmith, LangGraph is generally it takes like a couple of like a second, more seconds, basically. Done, Babo, done. Okay, Saurav is installing. Fine. What about others, guys? Done. Fine. Saurav done. Raj done. What about others? Do it quickly, everyone. Okay, Tabi's done. Fine. Done, everyone. In a chat, please. I'm waiting for your done. Okay. So now let's move ahead. And then here, so what we can try to do, so we can try to basically do import OS. So here, first of all, just try to do a import OS. And then we can try to basically create two variable, let's say. So open AI API key, key. And we can try to basically keep my OpenAI key over here. So let me keep it here. Okay. So here is my OpenAI key. Along with OpenAI key, what I'm supposed to do, so I'm supposed to basically create a variable, so where I can try to keep LangSmith API key. LangSmith API key. Fine. So I have already copied that key, I believe. Yes, that's already available here. So I can try to copy it, and then I can try to just keep it inside this particular variable. So these are the two key which was required. And yes, I have copied this particular key. Then try to call this one. So os dot set environment or os dot en environ. And then inside that, so you can try to basically set OpenAI API key. So this is equals to basically this one. In a production system, so obviously you have to keep it inside a env when you are trying to do a local development, and then if you are trying to deploy this thing, so obviously you have to keep it inside a secret manager. So again, this is not advisable to, like, do a coding in this particular manner when you are trying to do a coding for a production environment. As I'm just trying to show you all of these things, so that's the reason I'm trying to keep it in this particular manner so that everything will be visible to you. But in a production, I believe we have already discussed and we are already aware about it. So Environ, and then here, so we can try to set basically a LangSmith API key. LangSmith API key is equals to this one. So whatsoever will be here, so it will be assigned in this particular place. Now, again, apart from this, so os.environ, so we have to set a couple of more things to use a LangSmith. So one is basically LangSmith tracing, LangSmith, and then underscore tracing tracing. So here we have to keep it enabled. So we can try to keep it as a true, true, a small true. So true, true, so that it will be able to trace each and everything that is going to happen with respect to an agent and with respect to our tools and LLMs. True, true. Fine. So language means tracing is equals to true. And then os dot environ. And then here, so we can try to call LangSmith, LangSmith, LangSmith underscore project, and I can try to give a project name. So whatsoever you want, you can try to do it. So I'm trying to build 10 agent agent for testing. Fine. So this is a project name which I have given over here. So it is going to take this particular as a project name. Fine, everyone. So these are the things, these are the information that you have to set, and now it will be able to technically trace each and everything. So now it is basically set. So it's just like setting a log, right? So here it will try to call a LangSmith, and it is going to log it in their cloud environment. So not in my local system directly, it is going to export all of this data, all of this log over there. And from there, you will be able to check, you will be able to trace each and everything. So fine, let's try to execute it. And yes, everything looks good to me. Let me ping you this piece of the code. Yeah. So now you can try to use this one. Just try to set your API key. That's it for LangSmith and OpenAI. Now here, so every agent that we are going to create, so that is going to require its brain. So brain means obviously I have to pass their like a LLM, basically LLM details I'm supposed to pass. So to pass a LLM detail, so let me create a a variable for a LLM. So to do that, I can try to do an import first of all that from LangChain OpenAI that we have installed. So import chat chat OpenAI. Fine. And then here, so I can try to create a LLM variable, and then chat OpenAI is going to help me out in terms of creating a LLM variable. So model is equals to, I can give a model name in this particular place. So maybe I'm trying to use maybe a GPT 4.1. This is quite old model, but yeah, lightweighted and good one. So model name is equal to chat GPT 4.1 mini. And then I can set a temperature. Yesterday also we have done the same thing. Temperature is equal to 0, so it is not going to hallucinate. Otherwise you can try to set any values between 0 to 1 basically. So closer to 1 means more hallucination, more random result, and closer to 0 means less randomness or less hallucination. So fine, this is how I'm going to create my LLM variable. Okay, so done everyone till this point. Excuse me. Okay, fine. So now let's move ahead. Let's try to execute it. Now here, so LLM variable I have created, and wherever it is required, so I'm going to call its brain. Means I'm going to call this variable. I will be having an access of this chat GPT 4.1 mini model. As simple as that. So wherever required, because in every agent creation, obviously I'm going to need it. Without this, I will not be able to do it. Now let's say if I have to test my LLMs, that whether my LLMs is working fine or not. So what I can do, I can simply call this LLM dot invoke. So LLM dot invoke, and here, so I can try to put my question. I mean, like technically a prompt, right? So tell me about yourself, self a bit. So this is basically my LLM, and I'm just trying to pass a prompt, ChatGPT prompt, and then I can try to execute it. And if I'm able to get an answer, so it simply means that my API key is working and my LLM is technically working. So I have just given a prompt. Tell me about yourself a bit. So sure, I'm a Chat GPT AI language model created by OpenAI. My main purpose, so basically, main purpose is to assist with answering question, providing explanation, generating a creative content, and all of these things. So yes, my LLM is working, and I'm able to receive a AI message. Right, I'm able to receive a AI message. So testing is done. Simple. LLM.invoke, and yes, I'm able to invoke it. Now let's go back and let's try to check basically my LangSmith over here. So I'm going to refresh it. And here, so if you will come to a tracing, you will be able to find out that this is the project which I have created, 10 agent for testing. This is the project name which I have given here, 10 agent for testing. This is the project name I have given. So it has started tracing it, by the way, guys. So this is my project. Now inside this project, what I have done one call, right? I have done one LLM call. So this is a one single call which I have done. And what I have done during this call, I will be able to trace it. So I said that I have given an input to this LLM, by the way, right? And GPT 4.1 mini model, which has taken, like, I mean, like, which has costed me this much, which has used basically this much of token. In very detail and depth, you will be able to trace each and everything. So at this date, which is today, 18/8, right? So at 28 past 45 p.m. GMT plus the 5.3 timeline, all those things. So it is, I'm trying to give this particular things as an input. Tell me about yourself a bit, and now this has generated this answer. So sure, I'm a Chat GPT AI language model, which we are able to see it even inside our console, right? So successfully, my LangSmith have started tracing each and everything. Are you able to see this trace, guys? Yes. Are you able to see this trace? Yeah. So if you are able to see this trace, it simply means that everything is working. Your LangSmith is working, first of all, means that LangSmith configuration that we have done. Your OpenAI key is working. You are able to create the LLM. So now you are good to go and good to go and, like, create agents. If this is not working, then even your agents are not going to work, and you will not be able to even trace your agents and tools and any things that you are going to do it, like right after this one. Yeah. So this is where the beautiful LangSmith comes into picture. Very easy to configure, right? Just have to give a project name. Just you have to set the status. Traceability is equal, tracing is equal to true, and LangSmith key. That's it. This is how simple this entire tracing job is. And going forward, as we will start executing our agents, we'll immediately come over here and we will be able to see that what agent is doing internally. Although I can see each and everything even in my console. So it's not like I have to come here, but yeah, I mean, like, this is giving you a beautiful UI, a structured UI. So it will help you out even in terms of understanding the internal mechanism and behavior of your agent, that from where to where basically your agent is going. So your agent will not look like a black box for you technically, right? So you will be able to trace it each and everything. Although I can trace it even in my console, I can understand each and everything even inside my console. Okay, fine, cool. Token, you are able to test how much cost it has given to you, this particular call, everything I will be able to basically test it. Even I will be able to do a evaluation. So each and everything, as you can see, I mean, like, everything and anything with respect to a LLM or agent security, you will be able to check it over here. You will be able to basically configure it over here. So it's a very powerful tool, very good one that people have like built so far, right? Yeah. So again, here you will be able to basically monitor that what is happening in terms of a graph, right? How many LLM calls is been technically done? What is the cost of the token? So it was 0.00002, I believe, right? What is a tool? So far, I have not called tool. So once I will start calling tool, you will see a graph even over here, right? What was a run type? So I have not done feedback scores. So everything you will be able to trace and monitor in this particular place in a beautiful dashboard, just like a Grafana. right? So you can say that it's a Grafana for LLMs and agents. Very, very simple, right? Grafana for LLMs and agents. Okay, fine, cool. Let's go ahead. And let's start creating a agents now. So testing is done. Fine, guys. Shall we move ahead? I'm getting no credit remaining way to solve this. Yeah, so in that case, you can add a credit. It will be solved. You can try to use any other provider as well. Even Uri AI gateway, you can try to like configure over there. At the end of the day, you just need a model access. That's it. Fine. So moving ahead, guys. Now here, so what we can do, so we can try to do some sort of a import if we have to build a agent. So let me ping you that import. Yeah. Couple of import we have done. So what we have done, let me talk about it. So here we have imported a type dictionary, literals, annotated. So all of these things are going to help me out in terms of doing a validation or in terms of passing the data. So as we will be like using it, I'll be talking about what is the actual meaning of a type dictionary or literals. These are the pre-built library. Then from LangChain core message, we are trying to import a human message, AI message, system message, and tool message. So human message means just a library, by the way. But yeah, so with the help of this, you will be able to pass your prompt. AI message means so whatsoever AI is going to respond back, right? For example, this one was AI message. For example, LLM has given me an output. So that was a AI message. So I will be able to check that one. System message means a behavioral prompt that you are going to set basically. So try to behave in this manner. You are not supposed to do this or that. That is technically called as system message. Tool message means, so let's say you are trying to create a function and then you are going to define the nature of the function. So what that function is going to do. So these are the different kind of messages which exist because you are trying to deal with agents. Now inside agent, there will be a LLMs, and LLMs understands basically English or maybe a language, any other languages it is going to understand. And based on those language understanding, it is going to do something. So this is where this messaging part we are trying to import so that we can try to use it. Now here LangChain core.tool. So I can try to create a tools out of this one. Yesterday we have done that. Now we are trying to import a graph. So a state graph, which is going to help me out to build the entire graph that, start from here, then do this, then do this, then based on this condition, go this direction or that direction. That will be a contextual one, right? Start end, so start of the process, end of the process. Message state, so what is a message technically we are trying to pass. So message just from a human, message which is a combination of a previous context and the current one, or maybe coming from some LLMs or maybe coming from the system. So this is something that we will be able to control. And here, so pre-built tool node and tool condition, we are trying to import just a library. So which I'm going to use it inside the LangGraph. So these are the major import you have to do, guys. So do the import, everyone. And if you are getting any kind of a issue in that case, you have to do the installation. So done, everyone. Are we able to import? And hopefully you will not get any kind of a issue if your installation is correct. If the above one is correct, then here it will never give you issue. Fine. Okay. And I will be using each and every one. And again, I will try to re-explain that why I'm using this one. Okay. So first of all, let's go and create a tool. Very simple tool I'm going to create, right? For example, yesterday I have created multiply and addition. Same kind of a tool I'm going to create. So here, def multiply is a function. So multiply is going to take a value. Value type is going to be float, float. And then it is going to take b as an input. And then it is going to be float or integer. And it is going to give me response as, let's say, float. Fine. Now here, so I'm going to maintain this doc string. Now this is very important. Yesterday even I told you, so whenever you are trying to write a function, a simple plain Pythonic function, it's completely fine if you're not going to mention a doc string. Although as a standard, you have to mention, by the way. But in case of a tool calling, means when this function will become tool, so how your LLMs will be able to check and understand that this tool is going to do this one. This is where this doc string plays a crucial role. So it's very important. So whatsoever you are going to do in this function, try to explain, try to describe in a very, very clear manner. If function is complex, describe everything, even the edge cases, that it will be able to do this, but not this, something like that. I mean, like the full story of the function, you have to define it over here so that LLM will be able to understand and decide that out of hundreds of tool, which one I'm supposed to call, right? Based on this particular description. So it should be very, very descriptive. So this function is going to take an input and then it is going to do a multiplication. So in general, user are supposed to pass basically a floating point number or integer for a value, both the values. So this is basically I have like a given as a description. As detailed as possible, it's a doc string, but yes, in case of a tooling, it is important. Tool calling, it's important. Then return wise, what will return? A into B, simple. So very, very simple function I have. Now, if I have to convert that into a tool, I will be just using a decorator coming from a LangChain, which is tool. This is the import I have done basically, right? This is the import I have done. So tool, and technically this is getting converted into a tool and I will be able to use it. Means I can attach it and LLM will be able to discover it, right? Because everything is mentioned and handled inside my LangChain core tool library itself. This is where this library comes into picture and it gives you a direct access, by the way, that okay, go and just use it. So this is one of my tool. Likewise, I can try to create maybe my another tool called as addition function, and then it is going to take again like a float. Float. So function can be any kind of a function as complex as possible. You can try to pass b float, and then it is going to give you return float, float, let's say, and then doc string. So this function is going to take integer or floating point number a and b respectively, and then it is going to give you a return as a like a summation of this function. You are not supposed to pass a string. You are always supposed to pass a floating point number or an integer or a numeric. Okay. So I have just given this entire doc string, the story over here. Now return a plus b. Fine. Now if I have to convert this into a tool, simple, I will do a decoration tool. And now it will be able to get that tool property. Make sense, guys? Yes. So two tool we are able to create, which is very simple one. I mean like addition, multiplication, nothing big for us. Yeah. So likewise, I can create a tool to access my Gmail, to perform read operation on my Gmail, to perform write operation on my Gmail, to access my WhatsApp, access my messages, access pictures, access basically a Google Drive, access basically my Slack, access basically my Discord, right? And then do a write operation, read operation, reply operation, whatsoever I want, I can just try to give it. And again, based on this doc string which I have given, my LLMs will be able to discover that, okay, fine. So this tool is doing this, just call this function and then that function is going to execute it. Maybe I can create some tool which will be accessing my SQL databases, right? So it's a function at the end of the day, right? We write. So here also we are writing that simple function, nothing different we are writing. As you can see, I'm just using a tool decorator, which is eventually converting this function into a tool, and LLM will be able to discover it with based on what? This one. Make sense? The understanding about the tools? Yes, everyone. So do you have any confusion, concern, what the tool is, how tool is going to discover it? I mean, like how LLMs are going to discover a tool, by the way, how it will decide which one I'm supposed to use, which one I'm not supposed to use. Clear? Quick, guys, everyone. So only the basis of dog string LLM will be able to select the tool. Yes. Yeah. Because LLMs are good with what? A language. Here we are writing what in a dog string? A language. Yes. Please share the doc string. Yeah, I've already done that. Just check the above one. It's same, right? I've just pinged you in the chat. It's there. Correct me if I'm wrong. As per the prompt, it will get to know what to do and when to choose. So, see, I have given a prompt that go and do this operation. Now, to do that operation, you have multiple tools, right? Or maybe you have a specific tool. So, how it will be able to check which one I'm supposed to use? Right? So you are going to give human message, right? You are going to give human message. Now, based on that human message, it is supposed to discover, right, that which function I'm supposed to call, because this function is going to give a system access. If I need to call third-party API, we need to decorate it with the tool. I mean, like wrap it up those APIs inside a function. That function will be calling, doing the request. It's common sense, guys. Very, very simple, right? How do we call API? We use a request function and then endpoint, right? And then we try to pass a header. It's not like you will just copy paste API and it will be able to call it, right? You have to pass a header, you have to pass basically a bearer token, if it is secure basically, and then you have to pass even a payload with the API endpoint. This is how you call API, right? Through a function. Yes, everyone. Yeah. So create that function, decorate it with the tool. Yes. Simple. Okay, cool. So these are the tool that I have created. Very simple one, basic one. I can create a complex one as well to call APIs, to call my databases, to call my, which I will be using it. But yeah, technically it's a function and we are not new about the function. We have written so many functions so far. So now here, what I will do, I'll try to create one dictionary. Sorry, I'll create a list over here because I have a multiple tool. So TOOLS tools is a list. And then here, so I'm going to keep this tool name. So one tool name is multiply, keep it here. And the other tool name is what? This add. So I'm going to keep it here. Just a variable, list variable, nothing much. You can give any other name that you want. Now, so tool is ready. Likewise, I can have hundred thousands of tools, right? Means hundred thousands of access of this entire world. Maybe access of my Word document, access of my Drive, access of my SQL databases, access of my graph databases, access of this, that, whatsoever it is, right? Graph database don't understand the natural language. Graph database always understands its own cipher query. SQL databases don't understand a natural language. SQL database always understands a SQL query. So every system understands it in its own language, right? So obviously, this LLMs are going to generate things, or maybe it is going to call things in the way that system understands. But LLM understands language basically. So let's just like a human, right? So here I have created a LLMs. This is my LLM, right? The LLM which I have used. So now I will try to attach these tools with the LLMs. So LLM dot function is already there, right? So LLM dot I can try to call by I'll try to call basically bind tools. Now here bind tools and just give a tool access. So now LLM is having a tool access. So LLM is not alone. It is not supposed to reply from its own capacity. It can even use my capacity. My capacity is what? My own custom function I have created. So here bind tools and then LLM, let's say I'm creating a variable with tools. So now this variable, technically invoking an LLMs, will be having these tool access as well. Okay, fine, cool. Let's execute it. Now after this, what I'm supposed to do, so this LLM endpoint I have created, now this LLM is having a tool access. I would like to use it, by the way. Yeah, I would like to basically use it. So to use it, let me create a function, basically agentic function. So def agent, I can name it anything. So agent node, and then I'm going to give a state. The state is equals to message state, by the way. So means there is a function which is going to take a input, right? A human message, a AI message, a system message, or any other message which I'm going to give. There are multiple messages which I can give, multiple type of the messages I will be able to give. So I'm just trying to create a variable state, and type of this variable is message state, so that I can pass a message. I can pass a prompt, technically in a layman manner, prompt. Now here, so LLM with tool, I'm going to call dot invoke. Now I'm executing it. Invoking means executing it. So invoke with what? So whosoever is going to pass a message inside this state. So here, message inside this state. So it is going to invoke it, and it will give you a response, right? So whenever someone is going to pass a message that do a multiplication, do a addition, simple, it will come to this one, invoke it, and pass that prompt over here. Technically, that message is going to be human message. This message, the one that we have imported, right? So fine. Message state we are trying to pass, and yes, this is what it is going to do. So it will give me response. Out of response, I will try to basically extract it, right? I will try to maybe return it. So return what? So return whatsoever you want. So message is coming from what? Response. So this variable, I'm just trying to return it. You can just give some different return type. That's okay. So here I'm trying to basically return it in this particular structure. Okay. So this is what this agent node is going to basically do, guys. So this is one of the function I have created, and this is eventually going to create one of my node. So basically it is going to create this one. in a graph state, it is going to create this one. So this agent node, which will be having LLM with tool access, right? Because this is the variable which I'm using, the variable which I have created over here, which is having this multiply and addition tool access. Okay, fine. Now we can move to the next. So till this point, we are just trying to create a background, right? We're just trying to create a background. So I have not created a real graph so far. A graph means basically like there will be a start, then there will be a LLM call, then LLM will call the tools if it is required. If it is not required, it will try to respond from its own, because I just have two tools, right? Multiply and addition. What if user is going to pass something like tell me about yourself? So obviously it will not be able to use multiply and addition. It has to use its own brain in that situation, right? So it will be able to use these two tools only in these two conditions, only in this kind of an input. In other kind of an input, it will not be able to use it or never be able to technically use it. Okay, cool. So let's start creating a graph now, right? Graph now. And this is where this import comes into picture called as state graph. Somewhere we have done the import, right? State graph, this one. So this is going to help me out in terms of orchestrating the entire graph, by the way. So here I can try to create a variable called as builder. Let's say BYLDER, builder, and then state graph. Fine. So graph, basically we are trying to instantiate. So message state, we are going to basically pass in this particular place. And then we can just do this object builder dot add node. So add node. Node is going to be what? So first of all, I'm going to add a agent node over here. So I can give a name to it, and then I can try to call this function, this one. So this node. That okay, this is one of my nodes. So means one circle I have created over here. Then I can try to basically like attach maybe a tool to it. So builder dot add node, and then here, so I can try to provide TOOLS tools, and then here, so tool node, I can try to basically add. So have I created here? I have created tools, right? I have not created a tool node. Let me create a tool node because that will be important. So tool node is nothing but just pass a tools over here. Eventually it will be a tool node and save it in some variable. So let's say I'm saving it in a tool underscore node. Fine. So it will be having now tool access. So this variable I'm going to pass. So there are the two node I have created basically. So one is so tool node. Fine. So two node I have basically created. Now I have to combine these two nodes at the end of the day. So I can try to call this same variable builder dot add, not add node. So add basically edge, just a connection I'm trying to create in between. So add edge means what? So first of all, start. So start is a state which I have already done as an import. As you can see, start. So start first of all, right? And then from start, you should go to what? You should go to a agent that I have created. So this one which I have created. So here I'm trying to create the complete binding, the agent which I have created. And then builder dot add. So here add conditional edge. So here we are trying to say that you have started, now you went to the agent, right? Now I'm trying to give you the conditional edge over here, that from agent, right, you can go to tools conditions. You can go to a tools condition. And then from here, basically, builder dot add edge, you can even go to, I'll explain you this one in a graphical manner, tools that I have created over here and agent. So fine, this is going to build my graph. And then what I can do, I can just call agent, my agent name, final agent name, simple dot agent. Let's say I'm calling, and then I'm going to call basically builder dot compile. Now execute it. Now, if I'm going to show you this print, this one, so you will be able to see this one. Now, this is replicating the exact same thing which I have written over here. So this is basically a object which I'm trying to create, which is going to help me out to create my graph, the state graph, basically. Then add a node agent, right? So this is a node which I have added over here, agent node in this particular place. And then add a node tools which I have added. So there is another node called as tool. You will be able to find out. Fine. Now here, so these are the two node which I have created. Now I'm trying to combine it. So in this three line, I'm trying to combine it. So I'm trying to combine it what and how. So I'm saying that okay, do one thing. So take a start state. So start state is a part of library which I have already imported over here. So start from here, right? Basically, and then do one thing. Go to the agent. So start state and then call the agent for whatever message anyone is going to pass, for whatever input anyone is going to give. Start from the start state, which is the inbuilt state, and then go to the agent which I have basically built. What is my agent? This is my agent, right? This is my agent node. So go to my agent. So where this LLM access will be there, plus LLM will be having a tool access eventually. Okay, cool. Agent. And then what you are supposed to do, so add a conditional edge. Conditional edge means this bifurcation that you are able to see, that whether I should call a tool or I should not call a tool. Because like I said, if I'm asking about a multiplication or addition, obviously it should call my tool and then give me the answer. But if I'm asking, tell me about yourself, tell me about data science, tell me about agentic AI, for that I have not created a tool. So obviously it will give you a response from its own capacity, right? From its own capacity. Or maybe if you are going to keep a condition that no, do not give a response from its own capacity, end it. So it will go and end it, as simple as that. So this is where we are trying to call the agent. After agent, we are giving a tool condition, right? So either go to the tool or maybe to the end. So here you will be able to see two arrows. So one here and one here. So either I'll go to a tool, either I'll go to a end. If I'm going to a tool, I need a response back, right? I need a response back that, okay, fine. So from this tool, maybe multiplication tool I have used, and then I am giving you a response back. So this is how this entire thing. So add edge, tool to agent. So this is a edge that we have created. So if tool I'm using, so tool to basically agent, I will be able to see the response. I will be able to see the response. So this is my condition and this is my back. So are we able to understand these five lines, guys? What this five line is doing and how it is going to behave? Are we able to understand this? Yes, easy, right? Yes, everyone. So let me ping you. I think till this point I have already pinged you. So from here, so easy, I believe, easy to create a tool and bind it to the LLMs and then creating an agent. And now I'm able to even visualize it, that what this code means. So I believe this piece of code is not a black box for any one of you. Any question here? The agent, simple agent that we have created, first agent, the first one that we have written. Question, guys, in the chat quickly. I'm not able to see the graph getting generated in my case after. So just compile this one. It will be able to give you, or maybe if you're storing into a variable, it will be able to show you here. Yeah, simple. Now let's move ahead, guys. And now let's try to understand the next part. Yeah. Yes, it always works, by the way. It's a code, right? So if it works for me, it works for everyone. Now let's try to call it. Yeah. So here what we will do. So simple agent that we have created dot invoke. So to execute anything, so we can try to call invoke. And while invoking this one, so obviously we have to pass a data. We have to pass like a message. For example, here, uh, when I was trying to create this agent, so message state, I have to pass over here. So message wise, what I'm going to say, so I'm going to pass a message, let's say message, and this message is going to be basically human message I'm going to pass. Human message I'm going to pass. So human message wise, content is going to be, so whatsoever question I would like to ask. So let's say, uh, what is the what is the multiplication of 3 and 4? Fine. So this is a message which I'm going to basically pass in this particular format while invoking this agent, while using this agent. Now, if I'm going to like execute it, it will execute and it will give me some sort of a result. So maybe I can try to store it here. RESULT result. Fine. So execute. Now it's calling, right? And it failed. Bad request. V1 collection interrupt. Error code 400. Invalid message. Empty array with the minimum length during a task. Param message. Okay. So I think there is a spelling mistake. Parameter message. Messages. Yeah. Fine. It's fixed. It was like messages, by the way. Result. If I'm going to show you, so it is going to show you all of these results basically. So what is the multiplication of 3 and 4? This is a human message which I have sent. And then response meta information. Now I believe it was not able to use. So message which I'm trying to pass, I can pass it as a list. Okay, so this one, and inside that there should be a list. Fine. Tool message. It should basically work for me as well. No, it seems like it's not working because it would have given me a result in this situation. So, message, human message, content. Yeah, I mean, like even this should give me like a result. I don't see anything wrong in this one. No, there is something wrong. I'm getting a blank response. It should give me a response as well. So it is just trying to send the message, but not a response. Let me check my tracing. So many times I have executed. This is my recent one, it seems. Input, user. Yes, I told you, right? It is not giving me result. There is no output. Something is fishy. Something is wrong. I will have to fix it. So tool is fine. Tool is fine. Anyone who is able to get the response? Raj is getting a response. It should work. So tool is fine. Then multiply and add is fine. Agent node is fine. Tool node. I'm passing tools from here. Multiply and addition. This is also fine. Node wise fine. This structure is fine. Simple agent. This is the agent which I have created. And I'm trying to invoke it with the message. It's not able to generate the output. Simple agent. Basically, this should give me the output. I mean, like it should show me. I believe there is some cache issue, guys, because there is nothing wrong in this entire thing. So let me restart. It will work in the as it is in the existing state itself. It should work. Restarted. Fine. No. Message should preferably a list. Fine. And this one is not working. In agent node function, we need to write a message. I think there is a issue. So message, I mean, double S say state LLM tool, then invoke state, and then messages, return. Oh, messages, and then response. I'm trying to capture. Fine. It should work now, it seems. Ah, so there was one minor mistake, guys. So there was a spelling mistake. Messages. It should return messages, and as a response. So whatsoever will be here, it will be able to capture it. So now I'm able to see the messages. Now here, so if you'll go and see the messages, so instead of looking at this place, basically, so what we can do, so we can go to our LangSmith, and we can try to check it from here. Same thing, you will be able to check it from here as well. And yeah, so how many times we are running it? So every time we are able to trace it. So now I'm just trying to check my last run, which I have done. So if you'll come here, you will be able to see everything in very detail. Actually, this is the beauty of a LangSmith, that what you have done. So what user have done. So user have basically passed this input. What is a multiplication of 3 and 4? Right? This is what user have passed. And then what is the output? So basically to generate an output, this was the user message. What is a multiplication of 3 and 4? Then AI brain come into picture. See the brain, right? The brain part. Brain part means the brain, the yellow symbol. I believe you are able to see over here. Or let me magnify it a little bit. So here you will be able to see that basically your LLM came into picture, and this is what it is representing over here, the brain, the AI. Now this AI has decided that what I will do, I'll try to use a tool. So here you will be able to see a symbol of a tool. So based on your input, it is trying to decide that which tool I'm supposed to use. Obviously, you have given two tool access, right? So one is a multiply, one is a add option. This is what you have given. So it is basically calling which tool? Multiply tool. And then it is trying to multiply it. And then it is trying to basically hand over your entire things again to the AI. And then here, So AI is coming into picture and is telling you in a LLM way or in a language way by English language that multiplication of 3 and 4 is basically 12. So this is how this entire flow is happening internally. You can check input. Input is your human input, output wise. So this is how it has generated the output, right? And then on your left hand side, you will be able to see how it has built the entire graph. So there was an agent, then basically inside the agent, there was GPT 4.1 mini was there, and then there was a tool condition. So tool condition, the bifurcation that we have created. So it was actually called, the tool condition was called. Now out of this tool condition, it has technically called a tool, right? And then it has technically called basically tool based multiply. Then it has called a agent once again saying that okay fine, so I'm able to get the output after like passing this data over here, and then it is going to give you a final output as multiplication of this, and this is this much. And here, so in on a micro level, you will be able to understand that how much time which one is taking, right? So agent is taking how much of time, LLM is taking how much of time, conditioning is taking how much of time, multiplication is taking how much of time. So everything you will be able to trace it, and then you will be even able to optimize. If something is going to take more time, so you will be able to technically optimize it. So beautifully, I'm able to trace, and now I know that what has actually happened when I have basically called my entire agent. Make sense, everyone? Yes, make sense to all of us? Yeah. So this is like how easy it is. Now let's suppose I'm going to pass some different message over here. So I'll be passing maybe something where it will not be able to call the tools. So here I'll just call, tell me about yourself. Tell me about yourself. So this call is done. I'll go to my LangSmith and then I'll try to check the latest one. So basically here I have given, tell me about yourself. So is it doing a tool calling, guys? Is it doing a tool calling? Multiply or addition? No, right? So it is able to understand that this time I should not call any functions because I don't have an access of such kind of a functions, basically. Make sense? Yes. And proof, we are able to see it over here that how agent is basically behaving. So this is what agent is. So we are able to create a simple agent with a simple tool. Now let's go and create another kind of agent. By the way, the second kind of agent, we'll try to create it. So anyone who is having any question? I believe now we are able to understand what is agent, what is tool calling, how it works, how we can try to trace it basically, and how I can check what is happening after what. Yes, everyone? Yeah. Now, back to back, let's go ahead and let's start creating a multiple tools over here, right? Multiple tools over here. So here, what we can do, so we can move to the next part. So a simple agent we are able to now create. Now let's try to create a second kind of agent, which we have written over here. A reactive agent. What is the meaning of this one, guys? What is the meaning of this reactive agent? Quickly, anyone in chat? Whatever you were able to understand out of this reactive agent. Yes, reason and action in a loop, right? In a loop, it will keep on doing it, keep on doing it, keep on doing it unless and until basically like reasoning and then action means tool calling and then response, and just keep on doing it unless and until it is not going to finish the work, right? So fine, reason, action, observation, right? Then again, reason, action, observation, reason, action, observation. So in this manner, it will keep on doing it. Once it will be able to finish the task, then it's done basically. Okay, fine. So we are now going to create basically a reactive agent. I'll be using similar kind of a things. So let me go ahead and quickly use this three tool, multiply, addition, and divide this time. This three tool, I'm going to use it this time. Similar kind of a tool, we'll do it a little bit quickly as we are able to understand that these tools are nothing, just a function, piece of function. So these three tool I have created, multiply, add, and divide tool. Fine. Now let's try to create a list where I'm going to basically hold all of these three tools, and then with LLMs, I'm going to bind this tool. So a list, same as above, kept all the tools, multiply, add, and divide. Fine. And then I'm creating one more variable. So LLM dot bind tool. So I'm just binding it. So same operation, same thing that we have done. We are doing it over here. Nothing is different. Now let's try to create a reactive agent node. This is where you will be able to say that, okay, I'm able to create a reactive agent node. So let's try to understand how reactive agent node is been created, because that's the main thing, right? Because tool wise we understand that what is the meaning of that, why it has been created, how it has been created. This is also we understand that, okay, fine, so we are keeping it inside the list, and then we are just trying to bind it with the LLM so that I will be able to use this LLM, not just a vanilla LLM. So this is basically giving you a vanilla version of LLM. This is giving you basically LLM with the access of tool, technically, which is required in my agentic operation. Okay. Now the main part is creating that agent node, right? Even last time we have created that agent node, that was the main one, right? uh, this one agent node we have created. So this time also we are going to create a agent node. So let's go ahead. And it's again simple. So reactive agent node function I have created, same state message I'm going to pass, message state I'm going to pass, and here this is something that you are supposed to set and read out this one carefully, read out for this particular purpose. So here system message I'm trying to set, means nature of system I'm trying to set, and this is how it will be become a reactive one. Because reactive means what? Do a reasoning first, then call an action, and then get a response and keep on doing it unless and until you are not able to get the final result. So read out this message that we have written, and similar kind of a message you have to write when you are going to create any kind of a reactive agent, a system message you have to set. So content wise, I'm saying that you are a mathematical assistant, right? Use the available tool whenever arithmetic is required. You may call multiple tools if solving the problem requires a multiple steps, means multiple time reasoning, then multiple time maybe action, means tool calling is required, and multiple time responses is required. Keep on doing it. So I'm trying to set a nature of a system behavior basically, right? So this is where I'm trying to set my system message, and then I'm trying to call this react model, the LLM, right? The LLM that we have created, dot invoke. And invoke with what? Invoke not just with the message that user is passing. If you remember last time what we have done, so last time basically when we were trying to create an agent, so we were trying to basically invoke with what? Only a state message. What is the meaning of that? The message that we are trying to pass, a state message means a message which was available at that point of time. So a state message, right? So with that we are trying to pass it. This time what we are doing, almost we are doing the same thing, but what we are trying to say that, okay, a system message that we have set, use that one plus a state message and then invoke it, means then it will call the LLM. So fine, LLM will be able to understand that, okay, this is a nature I'm supposed to follow. This is the nature I'm supposed to follow. So if someone has asked me that what will be the something like that. So if question is going to be do 3 into 4 plus 5. So first we'll do 3 into 4, right? Or BODMAS rule it is going to apply first of all. I mean, like as per BODMAS, it is going to do the entire like a mathematical calculation. So that nature I can try to set basically over here, and then 3 into 4 plus this one, or maybe 4 plus 5 into 3. Whatsoever rule that we are going to set, it is going to basically apply that. And every time it is going to call a tool at the end of the day. So this is the only changes we have done in our return responses. There is no changes. So only two small changes. One, system message I'm trying to set, plus I'm trying to just send the system message along with the state message. Making sense, guys? The difference between the previous one and this one, the simple one and the reactive one. Yes, everyone? Any doubt, questions with this? Yeah. Okay. Now, so this is my actual agent, right? This is my actual agent. System message additional input in a reactive agent. Exactly. This is what we are doing, right? See? Yes. That's the only addition that we have done. It is coming from where? Here. This is the only addition. You can check with the previous method as well. And let me ping you this entire thing. So here I have pinged you this one. You can do the comparison. So this is the only changes, very, very small change we have done where we are passing system message as well. Now use this. Fine. Now same thing we'll be doing. So to create this entire agent things, same thing we are going to do. So we can copy the same part from here, right? Just copy the same thing from here to build this entire things and paste it over here. Here, so what is the changes that we are going to do? So whatsoever name that we have given, so just try to pass that particular name. So here, this is a React agent node. So I'll be giving that particular name over here, React agent node. Tool node wise, so here, React tool we have created, React tool. We have created. So just try to give a React tools over here. That's it. So React tool, right? React tool, I think I'll have to create it. Mm, 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 mm. Let me create React tool node, and then I'm going to pass basically React tool over here. This will eventually create a React tool for me. It's S. Fine. So React tools I'm going to create in this particular place. So React tool is done. And then start is equals to agent tools condition. Everything is going to be same. So I'm not going to change anything, by the way. Everything is going to be same, and then execute it. Fine. So here, if I'm going to show you my simple, not a simple agent, this time let me name it as a React agent. A React agent. Let's say I have named it React agent. It is going to be same, right? The only thing that we have changed over here is the behavior of the agent, the way it is supposed to behave. Fine. So now if I have to basically invoke this one, so let me give a problem statement to this reactive agent. So I'm saying that React agent dot invoke. So this one, it should invoke, right? And here human message wise, I'm trying to provide multiply 27 by 31. Add 100 to the result. So first of all, do this multiply, means first of all call my multiply tool and then try to add 100. So call my addition tool and then try to basically divide the final value by 5. So call my division. So can I say that it will first of all do a reasoning? Reasoning means it will first of all try to understand which tool this time I'm supposed to call, then what tool next time I'm supposed to call, then what tool next time I'm supposed to call. This will come from reasoning. This is the meaning of a reasoning. Understood, guys? Yes. So first it will do a reasoning. Then it will do a action, tool calling, multiply or maybe addition or maybe a divide. And then it will give you a response. And it will do these things 3 times. One time here, one time when it will try to perform this operation, and one time when it will try to perform this particular operation. So call it, right? Call it. Fine. Now I'll go here and I'll try to basically check. So what has happened basically with respect to my reactive agent, by the way. Okay. So here, what we have done, so this was my user input, multiply by 31, add 100 to the result, and then divide the final value. So this is my prompt. This is the prompt which we have given. So here you will be able to see that as it is a reactive one that we have created, right? And nature of the reactive one is, so keep on doing a reasoning and then action and then response, reasoning action response, reasoning action response, unless and until you are not going to complete the entire task. So here you will be able to see that it has called a tool, it has called basically a model multiple times. So first of all, it has called AI, which is a brain, and brain has decided that first of all I should call tool is equal to multiply. So called a tool, then multiplication result is basically this one. So this is the multiplication result I have received. Now after receiving this multiplication result, again brain came into picture, and brain said that okay, so now you have to basically add the result of multiply with 100. So this time you have to call add tool. So fine, it has done the addition over here. Then after doing that, brain again came into picture and said that whatsoever result that we have, so we have to basically divide it. So in this particular point of a time, it has to call basically a divide tool. Then brain has decided that okay, fine, so now I'm able to complete the job. So let me do the summary of this entire job. The result of multiplying this by this, then adding 100 to result, and finally dividing by 5 is 187.4. So this is where it has done reasoning action output, reasoning action output, a response. Make sense, everyone? How this has behaved technically? Yes. So clear how we are able to build a reactive agent and how it is performing in a backend. So how brain is getting called, then tool is getting called, then again brain, again tool, again brain, again tool. Yeah. So every time it is trying to repeat the process unless and until it is not going to complete it. And everything is happening out of what? So what extra we have done? Quickly, guys, what extra we have done to create a reactive agent? So basically, we have just given instruction to a brain that okay, you should behave in this manner, right? The system message that we have set. So technically, what does that mean? So we have given instruction to your brain that you should only behave in this manner. You should not behave in other manner. Yeah, technically that's a system message, which is setting your LLM behavior. So are you able to correlate, guys, how agents are working? Yes, and how we are able to control its behavior? Okay, so if I ask a different question, tell me about yourself, would it not work? Let's go and check. It should work, by the way, but it should not call the tool. So I'll be like, calling the same thing. And then let's say, my prompt wise, tell me about yourself. Fine, execute, done. And then I'll go back again. And then here, so let's check. Tell me about yourself. Simple. So brain has decided not to use a tool. So this is where tool condition comes into picture, right? We have, if you remember, even last time and this time, what we have done? We have done a tool condition, add conditional edge. Means either come to the end, means give a response and then come to the end. Otherwise, keep on calling the tool. Yeah. So code will always same when creating an agent. Almost you can say this is the skeleton that you are able to see, and this skeleton will keep on increasing. So when as your agents will be getting complex and complex and complex. Yeah. Simple. Now let's try to create third kind of a agent called as router agent, ROUTR, router agent. Now what router agent should do? Ideally, what it should do? Route the request. So you go there, you go there, you go there, right? Whenever there will be like, so for example, I'm trying to create an agent. So whenever, it should do a coding, for example, do some sort of a Fibonacci series kind of a calculation. So it should call my coding agent. Whenever I'm asking it to do some sort of a SQL operation. So it should call a SQL agent. Whenever I'm saying that, okay, go and do a research, it should call a research agent. Whenever I'm saying that, go and do some sort of a, operations with respect to generative AI. So it should be going and doing some sort of operation with respect to generative AI. So there must be someone who should decide that, okay, you go there, you go there, you go there, you go there, and it should follow the same lineage. And this is where this router, simple router, English meaning of router, right? As we understand. So again, even over here, it is going to do the same thing. So there will be some router which is going to decide, which is going to give instruction that you do this, you do this, you do that. Okay, it is very easy, by the way, right? It is very easy. So let's try to understand how router agent we can try to create. So to create a router agent, first of all, we should fix the output. And to fix the output, obviously, I'm going to use a pydantic. Pydantic is nothing new, right, everyone? Anyone who is not aware about pydantic? I believe I have discussed in my fast API classes. Yes, data validation, simple, right? So it is looking for this kind of a data. So I'll be looking for this kind of a data. So it will always validate over here. So here, a Pydantic class we are creating route decision, and I'm trying to call a base model. So eventually this will inherit Pydantic in nature, right? And here, so I'm trying to create a variable called as route and literals. Literal means out of this value it will be looking for, and this is the description that we are trying to give in this particular place. Let me close the bracket. Fine. So this is just a field description I'm trying to give. So there is a four different kind of a variable I'm trying to create, either a coding, either SQL, research, or general. It could be anything. So this is my simple output I'm looking for, right? Now, so I'm going to set a nature of LLM. So I'm going to say that okay, so whenever you are going to give me the output, so LLM with a structured output. So just try to follow this Pydantic class. Whenever you are giving me output, so your output should be coming from either of this. Basically, this is what I'm trying to say. Either of these four. This is what I'm trying to the LLMs. Fine. So let me ping you this Pydantic class. This is just for validation. Nothing much. I'm fixing my output. And then I'm setting up my LLM. That okay, fine. So you should give only this for output. Apart from that, I'm not expecting anything. Yeah. Now, so here again, let's try to create one more class, right? So route state, and which is going to call a dictionary in nature. So it will take question, it will give a route, and then it will try to capture the answer. Means route means what? So whenever question will come, there will be router, call it to come into picture. It will decide which route I have to go, means which agent I'm supposed to call. That agent will give a response, and that response will be captured and given to the next step, right? Or maybe to the end step, basically. So here I'm just trying to create a router state class just to take an input again in this particular place. Now let's create a actual agent, the actual node over here, the routing node. Let's try to create it. So after doing this data validation and setting up this one, so here to create a router node, again it's very simple, and it just depends upon the prompt. Router node, I'm passing a message just like the previous agent that we have created. So this is my routing agent, you can say. Node means agent, you can call it agent as well. So this is my routing agent, and I'm trying to call router LLM, this one. So which will be expecting an output in this format. So I'm fixing the format, by the way. So it will be invoked and will say route this user question to coding, this one, coding agent, if it is related to Python, Java API, bugs, or programming. Or route to this one if database queries or SQL. Route to this one if explanation, comparison, or investigation is mentioned. Route to this one everything else, right? And then question is equals to the question which we are getting from the state, from here, from the user, right? It will give a response. So I'm just trying to return the response. So decision of the route I'm trying to return out of this one. So this is what this node is going to do, this agent is going to do. So it will keep on routing things. Okay, so it will route a things, that's completely fine. It will route either to a coding, right? Either to a SQL, either to a research, either to a general, right? Either to a general, it is going to route it. Now, I need an agent. So if there is a coding, so obviously someone should solve that coding problem. Some agent should solve the coding problem. So I need a coding agent. I need a SQL agent. I need a research agent. I need a general agent as well. Because if I have routed, there must be some agent which should handle that request from that particular route, right? So router I have created, this router I have created. So it will route to either coding or SQL or research or general. Now, after that, I have to obviously create all of these four route. Let me create it. Again, this is just more like a prompt and similar kind of a nature. So coding agent state means it will get a message from where? This one, route, it will get the message. So here again, I'm invoking just a plain LLM. Plain LLM. Just remember, I'm not invoking this router. Plain LLM means whatsoever coding agent will get, I'm just passing that to my LLM. Okay, fine. So the user has asked this question, pass that to LLM. LLM will respond. I could have passed that to some other system as well. That's possible. But I'm trying to pass that to LLM. Simple. And whatsoever answer it is going to return, I'll take it. So coding agent is created. Now SQL agent. So whatsoever question will come, I'll simply pass to plain LLM, right? Plain LLM. Then it will give me the answer. So second agent I'm able to create. Then research agent basically. So here is my research agent. So again, plain LLM I'm trying to call. As simple as that. I can call something different as well. Maybe refer to some research paper, go and dig deeper into this directory or that. Then general agent. So again, plain LLM I'm trying to call. So just pass the question, just you are like chatting to the chat GPT and then it will give the answer. So this 4 agent which was required is now done, right? Is now basically done. Now I can try to basically create a routing function. So basically, this routing function will try to choose a route. So which route? So this is my a routing function. So which is going to take the state and it will try to return a state route. So which route it should go. So now these are the base which we have already created. One routing node, function for that, and then 4 agents. Routing 4 agents. So coding agent, SQL agent, research agent, and general agent I have created. Now what I will do, so now I'll try to build the entire graph, by the way. One by one, one by one, one by one, I'll try to build the graph. Now, if I have to build the graph, same philosophy I'm going to follow. This time, I will just try to put a router in between. That's it. I'll try to keep a router in between, but yeah, flow is going to be same for me. So here, state graph builder, I'm trying to create, add node. So the very first node is what? My router node. So which one will come into picture? This one will come into picture, the router node, the very first one. So here, whenever some request will come, here is my router node. So whenever it will start the process. So basically here, I'm creating my router node. Now from here, it will go to coding, it can go to SQL, it can go to maybe like research, it can go to a general. So this is a very first interfacing. I'm trying to do it in this particular place. Process is exact same, nothing different at all, right? Same library, same process. So add a node, router node. Now from router node, right? So basically, I'm trying to add one more node, add node, coding node. So add node, SQL node, add node, research node, add node, general node. So these 5 node I have created. This is just a node creation. So 5 node I have created. Now I have to combine those nodes. I have to basically define that how this will flow. So this will flow in this manner, the diagram which I have drawn in red. So 5 node is created. So router node, SQL node, coding node, research node, and a general node. All this 5 node is created. Now here, so I will start binding it. So first of all, add edge. So start this one, right? And then when you are trying to start, so I'm trying to build a connection. So start to router node is a very first connection. So as you can see in my diagram, then I'm trying to add a conditional edges from router. And here I'm trying to call a function which I have created, choose agent, based on the router output. That okay, either go with coding or go with SQL or go with research or go with general. And here is a pydantic validation. Automatically it will be done, right? So these 4 things. And then I'm trying to basically add edges. So if it is going to a coding, end, SQL end, research end, general end, means if I have sent something to the coding, router has sent something to the coding, fine, whatsoever response it has given, give it to the user, close it. SQL, give it to the user, close it. Research, give it to the user, close it. General, give it to the user and close it. So now if I'm going to execute this one, and if I'm going to show you in graph, you will be able to see the exact same thing. Yeah. So see the diagram which I have drawn. So it is like resembling the same thing. Start, first of all, and after start, go to the router. Now router will decide where I have to send, whether coding or general or research or end, and everything will come to the end, means to the user output. So is this structure and creation understood, guys, to every one of us? Yeah. Same thing I have used. I'm just trying to keep a router in between, and based on the response of the router, it is trying to choose the agent. That's it, right? Nothing different we are trying to do over here. Yes. Can we also say that router agent is also acting like a React agent? See, you can call that routing agent as a reactive agent if it will try to call. Reactive agent means what? Reasoning, first of all, and then action, and then response, and then reasoning. But are we doing it? Can I say that after one lap, basically, if I'm sending something to the coding, whatever response I'm getting, I'm closing it. So can I say that I'm not getting into the loop once again? If I can try to add, like after coding, try to again do the validation, or maybe like dig deeper into like a further after coding. So like, break it down into the next step, the next step, the next step, means keep on doing reasoning, action, response, reasoning, action, response. Then only I will say that as a reactive one. Can I say this is not a reactive one? Yes. Yeah. So we are defining the agents over here such as SQL. Yes, this is what we have done, right? This was just a function, by the way. I'm calling LLM inside this. Yeah. So this is not a reactive one. Basically, this is a routing one. If it can, I can try to, instead of sending to the end, right? If I can again attach a next layer and say that, okay, fine. So again, do the reasoning again, like, do the action, and then again try to basically do the responses and keep on doing it unless and until you are not going to finish the complete job. Then I will say that, okay, fine. It's a routing plus reactive. So I can create that kind of agent as well. So now here, let's go and test it basically. Yeah, let's go and test it. So let's try to pass some message over here. Let's invoke this routing agent. So I'm going to pass the one. So question is, write a SQL to find a top 5 customer by total purchase. And this is my question. Then route, I'm not giving answer. It's blank. So in this format, it is supposed to basically call. Let's see. So how it is going to work and behave. Okay. So I'll go to my LangSmith. I'll try to check over here. So how this call has been actually like made. So here you will be able to see that how it is behaving basically, right? So my question was basically write a SQL to find a top 5 customer by total purchase. What it has done, see the answer. It has written the entire SQL query for me. So basically, which route it has chosen this time? It has chosen basically a SQL route. Yes. Can I say that it has basically chosen a SQL route? So route I'm able to see it. So correct route it is able to choose based on the SQL. Now, if I'm going to say same thing, let's say I'm going to change my question over here. So write basically a program in a Java, for a Fibonacci series. Fine. So this is one of my this time it should choose a routing. Routing is equal to coding. This time it should choose. So let's execute and let's go and observe. So the next one, and this time write a program in Java for Fibonacci series. Answer. So, and what is the route? So yes, correctly it is able to choose the route. Can I say that it is able to choose the correct route? Yes, everyone. So let's say if I'm trying to solve a problem that access my Gmail, access my Skype, Skype is anyhow like it's closed. So access my basically Discord, access my Telegram, access my WhatsApp. So based on your message, it is going to choose that which one I'm supposed to call and which one I'm supposed to execute or access my SQL system, my databases, right? So you can give hundreds of agent access. It will be able to decide which one to choose. And yes, it is able to decide precisely. So means my routing is working properly. Let's say I'm going to ask a general question, right? I'm going to ask a general question that input wise, let's say if I'm saying that, tell me about future of quantum computation. Execute. It should call general one, right? It should not choose like a SQL or maybe something, maybe research it could choose. Yeah, that's also okay. So now let's see. Tell me about the future of quantum computation. Router is, what is the router it has called this time? Research router. It felt like I should call a research router for quantum computation. Make sense, guys? Yeah. So now we are able to build the routing agent, and yes, routing is working perfectly fine. It is able to behave the way I have built it, right? The way literally I have built it. So in the exact similar manner, it is behaving. So not even a single time it has given me a incorrect output. Yeah, incorrect output. So amazing. My agent is working, by the way, and I can see it, by the way. Yeah. So again, like core philosophy is same. Create a node. in a Lang graph. Connect it. The way you are going to connect, it is going to behave in the same manner. As simple as that. Then I can try to create a next agent, basically a planning agent, right? So let's go and try to create basically a fourth agent called as planning agent. Quick, it will be quick, similar kind of a things with little bit of modification. So planning agent. Now, what is the meaning of planning agent basically? So basically, there will be a goal I'm going to assign to that particular agent. That agent is going to plan in a step by step manner. That first do this, then do this, then do this, then do this to execute this entire big process. This is called as planning, right? So let's say if I have to create or if I have to construct a 10-story building, so obviously, I can't start with the pillar and all those things. So first of all, I have to plan about the material, about the resources, about safety, security, and then floor by floor, layer by layer. So I will start building it. I'll start finishing it, right? Keeping everything in the mind. So this is where planning agent comes into picture. So when you have to do a big task, for example, a big IT project, if I'm doing, obviously planning is required. In one shot, you will not be able to build it. No one can build it, by the way. So planning is required. So this is where this planning kind of a agent comes into picture. So let me create a pydentic for a planning. Yeah. So pydentic for a plan is class plan base model. So task can be a list of the task anyone can give. This is just a pydentic validation. Means it is going to convert that into a list of the task. Means the output basically. Planning is state wise. So here there will be a goal, task, current task, result, and final answer. So basically, this is what the final output which I will be expecting. Same as before. Now here, so let's create my LLM. So LLM dot with a structured output. So I'm trying to pass a plan over here. So I'm just trying to pass the plan. That okay, fine. So give me a list of the task as a part of the plan. So this is my LLM. I'm trying to set just the way I was trying to set the other one. Then let's try to create the agent, by the way, the agent. So here there is a planner agent or planner node I will be creating, which is going to take a human message, right? And it is going to call this LLM invoke, which is eventually going to give me this as an a goal, task, current state. In this way, I'm going to ask the things, and then it is going to give me the response. So break this goal into maximum 3 small tasks. I can say 30 small tasks. It will break down, simple, right? And then it is going to return. So simple, it's a LLM call, right? LLM call. So where LLM is having a certain restrictions that whenever you are getting called, you should always call with the list of the plan. So means at least three list of the breakdowns I'm looking for. Now here, so then what we are going to do? So we are going to basically create the executor one. Yeah, the executor one. So again, another function. No, not this one. Executor one. Yeah. So executor one. So executor one is going to take the message, by the way, right? And then it is going to check the current task out of the message, and then basically a task index it is going to create, because there will be multiple tasks, task number 1, then 2, then 3, or here I'm saying 3, maybe 30. So index by index you will go to a task to task, and then it will try to basically break it down, and it will give you a result that what was the original goal of task number 1, what is the current task it is doing, what is a previous task which was there. So for every task it is going to give you this result. This is what executor is doing, nothing much, simple. So it's just a function, and I'm just trying to basically configure it in this particular manner, and then it is going to return the entire result, simple. Okay, so this is done. Now here, so I can try to basically, create one more function called as more task. It will try to check that whether there is more than 3 tasks or not. If there is a more than 3 tasks, then try to finish it. This is something that it is trying to do. Then here, so what we are going to do is that we are trying to create basically a synthesizer. So here what the synthesizer can do, so technically it is going to call the LLM invoke, and it will take goal, it will take a research result, and basically combine each and everything so that it can give a human read or human readable answer. So here this is what synthesizer will try to do it. Now coming to the next part, the final part, basically the build graph. So build graph wise, I'm trying to add a planner node. So one will plan, then another will execute, right? And then here, so we are trying to add a synthesizer, means combine the output, give it to the human readable format. So here, 3 nodes are there technically. I'm trying to connect those nodes. So first of all, planner, start to a planner, then planner to executor, then executor to a synthesizer. Simple. Check the more task and synthesize it and give me the final answer. So now if I'll show you in a graphical format, this is how my planning agent will technically look like. Simple. So starting, then it will go to the planner. Then from planner, it will break it down. It will go to the executor, right? If I have a more task, so in that case, keep on executing task number one, task number two, task number three, basically the goal and then like a result. If it is coming to the finish, then it's fine. So call the synthesizer, combine the output, give a result to the human. So this is basically a graph I have created technically, right? Okay, now go ahead and let's try to test it. So here I'm going to invoke my planning agent and I'm going to say that your goal is what? And goal I'm giving in what format? The class which I have, dictionary class that I have created. So here planning state, goal, task, current task, result, final answer. Okay. So here I'm trying to basically give input goal is equal to compare Python, Java, and Go for building a backend API and recommend one for a startup. Fine. So task list is blank. It will decide. It will be decided by basically like agent. Current task planner basically. Current task is 0. Result is nothing. Final answer is nothing. So this is my goal that I have given. Now let me execute it. Let's see what will happen in a backend. Okay, so execution done. Now let's go and check here what has happened this time. So here the goal was compare Python, Java, and Go for building a backend API. So many calls it has done. See, so compare Python, Java, and Go for building a backend API and recommend one of the startup. Fine, this is my goal. Now output wise, what it has done. So to generate this entire output, the final answer is for building a backend API. So basically, this is where synthesizer comes into picture. So out of synthesizer, I'm getting this one. For building a backend API in a startup environment, here is the concise comparison and recommendation for Python, Java, and Go. Python, strength, then weakness, and then best for Java, same. For Go, same. Final recommendation, it is trying to build out of synthesizer. For most startup, go to the option and decide to choose this, right? Now here, compare Python, Java, this. Current task is 3, result. So basically, it has broken down things into 3 tasks: Python task, Java task, and Go task. Then it is getting a summary, recommendation. Then again, analysis factor important for the startup. It is trying to do. Then after, so cost estimation, scalability, community support, it is trying to do. Then considering the comparison. So these 3 things in which it has divided the task. One is basically a selection, basic selection. Then again, another one is analysis, and then the consideration and comparison. And then this is a final comparison. It is able to give it to you. Again, so research, analysis factor, and then comparison. So first of all, research it has done on strength and weakness of Python, Java, and Go. Analyze the factor and then compare. It has done. And here you will be able to see which one is doing what. So planner is calling. So first of all, graph, then planner will be called. What this planner is trying to do? So planner is trying to basically perform this operation. Then this one will come into picture, give the answer. This one, output, raw output. Then executor will come into picture. Then basically like again executor, more task will come into picture. It will try to break down further. Executor will come into picture. This one will come into picture. So this is the current flow of your entire things and then synthesizer that synthesize the entire result and give it to me. So fine, as a synthesizer, you will be able to get this entire answer. So everything we are able to trace it in this particular one. So make sense, guys? The planning agent. Yes. And rest of the things like time and tokens, everything we are able to trace it in every steps. Yes. So shall we move ahead? Yeah. Okay. So now next one that we are going to create is a reflection agent, right? So reflection simply means that I'm doing some task, but yeah, I have to cross check that whether I'm right or whether I'm wrong. So here there will be like something called as critic I'm going to create, and it's like the responsibility is to check me, keep in check on me that okay, so whether I'm able to reflect on myself or not. And if I'm wrong, then in that case, I have to rectify it. So this is where a reflection agent comes into picture, which is a fifth agent for today. So here, let's go ahead and let's try to build the reflection agent first of all. So here, I'm going to create a identity class. So which is going to give you two output. One is true or false, means basically approved or disapproved, and then a feedback, right? So if I'm right or wrong, so obviously this will be captured here as an output, and then like feedback that why I'm right, why I'm wrong. So this is my identity class. Now this is my input nature. So sorry. So topic I'm going to give draft feedback approved iterations. So I'm going to give. Now here, so let's try to do one thing. So let's try to create one node, a generator one. So where I'm taking a message from the user, I'm calling the LLMs. Write a short 4-line explanation of whatever topic that someone has given. So let's say someone is saying that write about a data science, maybe a story, right? I'll write a story. Now, maybe my story is going to be wrong. Maybe my story is going to be right. Depends, right? So I have to reflect back. Basically, I have to reflect back that, okay, so, basically my story is not correct, basically. So I have to rectify it. I have to basically rewrite it. So this is where it is going to call this one. Write a short 4-line explanation of whatever topic. So it is going to generate that answer. So let's say it has generated one LLM has generated. I can even involve multiple LLMs over here. One from ChatGPT, which is actually generating, and another Gemini or Claude, which is going to test it because it's a LLM call at the end of the day. So maybe I can create another variable called LLM1, 2, or LLM GPT or LLM Gemini, right? Even we do that in case of this kind of agents. So now it is going to give you a generation. Once some content is been generated, right? So then we are going to basically create a LM with a critic in nature, critic class. Critic class is what? This one. So which is going to give you two output, approved or feedback. So this LLM, fine. Now here, so as you have you have to create a critic, by the way. So you have to create a critic node as well, critic agent as well. So again, critic LLM dot invoke means in this format, give me the output. In this format, give me the output. And here I'm giving a simple prompt that evaluate the following explanation: requirements, technically correct or not, simple or not, understandable by beginner or not, concise or not. So you have asked me to write a poem or maybe a story on data science. I have written that. Now this critic will try to check based on this prompt, right? That whether it's a technically correct or not, simple or not, it can be understood by a beginner or not, concise or not, right? So it is going to check based on these pointers. We can try to even make this prompt very, very big as per my requirement. And then a draft. So basically based on the draft, whatever input it will get from the generator, and approve only if it is good enough. So fine, it is going to call true or false. And it will be approved or it will be technically disapproved. Yeah. Now, so critic is one. So let's say critic has given me a bad feedback and critic has not approved it. Critic is telling me approved is equal to false, right? So critic is giving me answer in two manner as per Pydantic. So either it is going to give me false, and then feedback is you have to revise. So if critic is giving me a bad feedback, so obviously I need a node, I need an agent which will rewrite as per the feedback of the critic, right? So for example, you are chatting with ChatGPT. If it is not giving you good response, you give more prompt. So similarly, so here I'm creating a new node, revise, and we'll try to call llm.invoke, improve this answer. Original topic was this, draft was this, and then critic feedback, which is coming from here, is this one. So again, this is our LLM, simple vanilla LLM I'm calling, and then it is going to give me the final one. So three node I have created. One which will generate, which will answer immediately. Second, which will evaluate that answer and tell you whether it's good or bad. Third, if it is bad, go and revise, right? Go and revise. So this is my revise agent, which will come into picture. Okay, cool. Now reflection, a decision. So let me create one more over here, reflection of the decision. So if state approved, then return done. Means no need to do anything. Maximum at max, like iteration is more than two. So if iteration is more than two, don't go for infinite loop. I mean, like, do not revise again and again and again. There is a possibility that it will go in an infinite loop. So I'm breaking that loop over here by saying that do not go beyond two. And then here, so everything is done. Now my responsibility is to create a graph. So simple in graph wise, I'll create a node agents, and then edge means connected. As simple as that. So the way we have done in other one, same thing we are going to do it here. A state graph, add node. So first generate, whenever someone will send a message, generate it, write a story. Then critic will come into picture, validate the story. So that node, and then edge. So first of all, start and send to generate. From generate, send to critic, connection. Then for conditional node, if critic, so reflect the decision. So if done, end, otherwise revise, then revise it. So I'm trying to add this edge. Now if I'm going to show you this graph, so this is how my graph looks like. Yeah. So start, generate, critic. If critic is done, in that case, end it. Means if like critic has given the positive response. If critic has not given a positive response, then revise and again send it to the critic. Do it for 2 times max to max, right? So that's my graph actually, on which I'm going to technically work. Fine. Now let's try to execute this graph and let's see how it is going to basically work. So I'm going to ask a question that what is a vector database, right? What is a vector database? This is the answer which I'm supposed to give. Now execute. Executed. Now let's go ahead and let's try to check my execution. So here what has happened? So first of all, what is a vector database? So output was basically this was the draft output. Now it went for the feedback, right? So the feedback is the explanation is technically accurate, simple and concise. It's clearly defined what is vector database is, the type of the data is type of the data it handles, and practically applications. This is the feedback. So technically it was approved, right? Can you think about one thing where it will fail so that it can do multiple iterations? It can do a revision, a reflection, by the way. Can you suggest me the prompt? Yes. Can you suggest me the prompt where it will actually call the reflection? Just execute it multiple times. No idea? I'm saying, tell me about Raj Kamal. Fine. ChatGPT is having no idea about Raj Kamal. Let's see what happens. Yeah. Can vector database works as a SQL query? It will be able to give you correct answer. See, it's a GPT, right? It is having a world's knowledge. So ask something which it is not aware about. So I'm asking this question. Tell me about Raj Kamal. Probably it will do the reflection. So here, if I'll go and check. So, okay, input was tell me about Raj Kamal, approved false, right? Approved false. And then again, it has basically created Raj Kamal is a common name, may refer to the multiple this. The explanation is technically correct and simple. And then it is telling me approved is equals to true. So second time it is trying to tell me that it is basically true. Let me do one thing. So I'll just change this equal to uh, 10. Hmm. Okay, so first time approve false. Then second time, no, I should have something different. Iterations, we are passing explicitly, right? Let me change that one. Iteration is equals to 10. It is overriding. So now iteration is equal to 10, fine. It is not going for, it's very smart. GPT is like, So Raj Kamal, the music composer, he was known for his work in Indian cinema. More detail for a precise, will provide more detail for a precise explanation. Okay, I mean, like, answer is good. So it's not like going for the reflection. So critic is like, approving it, by the way. I should ask something where critic will disapprove. Let me think about some question. Uh, what will happen after 1,000 year? Some vague, some random question. I'm just trying to prove the reflection, by the way. It is like, giving a correct answer in 1,000 year, the earth will continue evolving. Technically correct. Explain the technically correct, simple, concise. It used to accessible language suitable for the beginner. All of the future will be saved both in nature. Okay, let me tweak this agent a little bit. So what I will do, I'll go and change the critic prompt itself. So it should be simple, it should be concise, understandable by person with IQ 200. Technically correct, and even it must have given a logic behind it. So I'm just trying to change the nature of the critic so that it can go for a false for the very first time. I'm just changing my critic. Everything is same. We can change temperature over here. We can play with temperature as well. I'm just trying to show you that it should go for the next one. That's my purpose is like reflection, because when you will read the answer, right? So actually, answer is correct, and it depends upon my critic as well. So how I have configured my critic. So I think this time it went for the longer iterations. Looks like yes, yes, yes. It looks like. So generate, and then this one. So generated, and then GPT-1, right? And then critique has given approved is equal to false, it seems, right? So the feedback is the explanation is simple and concise, but it lacks technical correctness and logical reasoning. See, yes, now I'm able to show you the reflection, right? Now I'm able to show you with this one. So what I have done, I have just changed, I have just tweaked my critic. I simply said that I don't know. Technical correct was the previous one, and even it must have a logic behind it. So you should give a logic. So first time when ChatGPT will try to generate something, so maybe it has not given a logic. It simply said that, oh no, this is what is going to happen after 1,000 year, and then understandable by a person with the IQ 200. So this is also I have changed. So basically now my critic will evaluate on that particular criteria. So it is saying that it makes a broad prediction without providing any underlying logic or evidence to support the claim. Yeah, so my critic is strong this time. Additionally, it does not meet the requirement of being understandable by a person with IQ 200. I have basically like mentioned that in my critic. It is following that. And as it does not believe into a complex and nuanced reasoning, to improve the explanation should include a specific example, logical correctness, and clearer rationales behind the anticipated changes. So again, it sent for the like next one, and then reasoning, then revision. So it is trying to call the revise over here. So here it is like calling the revise, then again sent to the critic, basically then EBT, and then reflection decision. Finally, I'm able to basically get it. So yeah, this is how like it is behaving, guys. By the way, so here now see the answer. It has given you a very long answer, right? And where my feedback is aligned means my critic is aligned. So iteration is equal to one. So in one iteration itself, in zero iteration failed, but yeah, one iteration itself, it is able to give you the final answer. So fine, guys, can we say we are able to build a reflection agent? Yes. So are you able to get the idea about the agents? I think we have seen a lot of agents today, right? At least five, I believe. This is the fifth one. Yeah. So do you have any confusion about agents? Like what is agent, how it works, behave, anything? I'll show you more, five more. I told you 10, right? So I'll show you five more. Not just that. So I'll even show you the evaluation of the agent. So how we can set the evaluation. So if it is going to fail, how I can restrict it, basically. I think using some dumb LLM is will go for a more iterations. Yeah, obviously. It will go for like more iterations. Right, it depends upon the critic, not LLM, by the way. It depends upon the critic, the one that you have given. So you can try to use a different LLM in critic and different LLM in draft, basically the one which is generating the output. You can use two different LLMs over there, right? Because at the end of the day I'm using that LLM object. So this is this, guys. Hope you have enjoyed this lecture and you are able to see how agent works and behave. What is a tool calling, by the way? How we can try to use a lang graph. Any question for me? Anyone? Anyone who is not able to understand anything like what we have discussed? I don't know, because next task is going to be on this one, and again, like you have to create a video and solve a lot of problems on that. And even in our RAG, agentic RAG, we are going to use it basically. Plus RAG eval, agentic evaluation, all these things we are going to do it based out of this one. So anyone, quick guys, Mr. Online already. Yeah, good for now. Good, cool. So hope all of you are able to learn a lot with respect to an agent. We'll learn much more things, right? Many more things basically in our like upcoming classes. By the way, just need more hands-on practice. Yeah, just write it, revise the same. You will get it. Believe me, you will get it. Yeah, and we have basically a LangSmith. So it simply means that whatever you are doing, you can observe. It will make your life and understanding even more clearer, right? You will not like go blank that what is happening I don't know, because whatever is happening you are able to see it, you are able to visualize it. But for now, I just want to know how you integrated voice typing in VS Code. I just use a whisper flow. So in my entire system, whether it's a WhatsApp or Telegram, whenever you will see a message from my side, right, I don't type it. I think I have left typing these messages I mean like 4 or 5 months back, even more, maybe 6 months back. So since when I've started using a whisper flow, that even works with my mobile. Yeah, it's a plugin basically. I'll show you whisper flow, right? It's already opened. See this one. So what it does, it try to capture my speech and then like immediately convert that. And it also rectifies the grammatical mistake. Yeah. So it's just a tool. You can go and you can download. It's a very famous one. And this company valuation is like a 2 billion, created by Indian, but not so Indian, I would say. I mean, like he's from Silicon Valley. I mean, like every startup has been created like there, most of them by Indian, Chinese, and everyone. But yeah, I mean, like we can't call them Indian. That's an amazing tool. Is it a paid one? Yeah, but their charges are very small. Like in INR, I believe they're charging around 400 rupees INR. So in terms of dollar, $4, $5, I believe. Yeah, only for $5. We are going to take separate class of LangChain, LangGraph. So what we have done, by the way? So what I was trying to do, so separate class. So I was already talking about LangGraph, right? What is your expectation? I mean, like just at looking at your question, I can see that you have not done anything. Maybe you're just like sitting and watching the lectures. That's it. Yes, right. Just asking. Why you asking then? Should not ask, right? Yeah, you should practice. You should solve more problems, by the way, which I'm going to give you. Don't worry. So fine, everyone. By tomorrow in your dashboard, you will be able to see a problem statement based on the discussion that I have done this week. Obviously, the agent discussion, and this discussion, I think it will require a couple of more classes, and then remember the project that we have started, will integrate it with the agents and the project, right? So that my entire loop will be closed, and then deployment as well. So we are going to use all of these things in that manner. So fine, everyone. Agent means the agent only in the world, right, sir? No, you can create more. And I think in the coming days you will be able to see more and more. But yeah, these are the type of the agent which I'm teaching you. You will end up using in any program project, or maybe to solve any things in general, even a complex problem, right? That's the reason so I have selected these 10 agents, so that in a sequence I can teach you. And then you can go and use any framework. You will end up using similar kind of a things. So I mean, like whether LangGraph or maybe like a LangChain or maybe like AutoGen, anything. When we are switching to Saturday, Sunday. Oh, okay. So I think I have not discussed this. I told you last week that this week we can have a discussion. So, guys, let me know about your slots. Sorry, not your mine, my slot. So, see, guys, my slot is available Saturday, Sunday, and you can advise which slot you want. So, I can schedule a class from 10, right? So, 10 to 12. Okay. So 1 p.m. IST, I can schedule, or I can schedule a 2 p.m. IST class, or I can schedule 3 p.m. IST class. So these are the three slots available to me for Saturday and Sunday. Now, advice. Which one do you want? Morning and evening slots are not available because it's like full. Yeah, Saurav is saying 1 p.m. Okay. Okay. So shall we do a voting in a group? Yeah, we'll do a poll, right? Anytime is fine, 1 p.m. Saturday, it will be Saturday, Sunday. So anyone can join like anytime, I believe. So if you will agree, then okay, I'll do one thing, because someone will say one, two, or three. I'll just do a voting, right? I'll just do a voting and let's go ahead with the voting. Saturday is working for me, so I will take a recording. Even working days will be working for you, right? Monday and Tuesday. Yeah. So fine. If everyone says that weekend is fine, because all the other Super 30 I'm taking on a weekend itself. So I'll so this week then you will be having again a class on Saturday, Sunday. So you don't have to wait for Monday. This week itself we'll be having again class on Saturday and Sunday. So continuation of this topic, agentic topic. And then I'll be talking about a RAG agent, then config. So first of all, 10 agent I'll complete, then like a agentic RAG. And then I'll like fall back to the project completion. Sundays working. So Saturday Sunday is good, that so that I can attend more live classes. Night shift employees. Yeah, I think it is a problem for many one of us. Like Monday Tuesday is not convenient. So let's switch back to Saturday Sunday, because for 95% people, I believe Saturday Sunday works always well as compared to weekdays. 1 p.m. IST is good for me too. Done then. Let's go with 1 p.m. IST. Decision done. I'll not do a poll. I'll just post it. That rest you guys can handle in your group. You guys can argue inside a group. I'm leaving that up to you, right? And you can convince your batchmates. Maybe you can fight for it. Yeah, I don't mind. LM Ops class is finished. No, who said it's finished? Because we have just done a small deployment. Okay, the LLM Ops and ML Ops, right? Yeah, that batch is finished. Not in your one. Yours one. That is finished like last week itself. That's the reason. So I have that slot available to me. So we have done a deployment with LLM Ops, ML Ops, and everything, and then we have finished the batch. But yes, again, it will be discussed in your batch as well, and many more other batches. Missed the last two. I think that was the important one. We must have attended that. But yeah, recording is available. So fine, everyone. With that, thank you so much. Take care. This Saturday, Sunday, 1 p.m. IST, we have a class. So let's join, and we'll continue with the same thing. We'll try to discuss about these agents in a practical manner. And I'm going to upload this one. So just before coming to the class, just do a little bit of revision and then come to the class. Revision of only the code part. Nothing else you have to revise. You will be able to understand, and you will be able to digest all these things. So fine with that. Thank you so much, guys. Take care. See you on Saturday, Sunday. I'll be like updating the time, and I'll make an announcement by tomorrow. And tomorrow you will see a task as well inside your dashboard. Thank you so much, everyone.